In this video, we are going to look at a different kind of factoring. We're going to be factoring a specific type of quadratic called difference of squares. So in order to understand what this is, it would be helpful if we practiced a little bit of vocabulary. So the word difference, if you remember from what you've done in your past, difference is the answer to a subtraction problem. So when we look at these quadratics, all of them will have a subtraction sign because we're looking at the difference of squares. All right, and the second word you need to be familiar with is squares. So remember, a number multiplied by itself is what it means to square something. And so in all of these types of problems, the things that we are going to be subtracting are things that have been squared. Well, if we're going to do that, it would be helpful if we had all the perfect squares listed out in one place so that we could remember what they were. Now, you memorized these in elementary school, but you may have forgotten, so we're going to put them together in a list. And normally you would need to have all of these memorized. You would need to be able to recognize them. Of course, there are lots of other square numbers. You can square numbers that are bigger than 12. However, if you have all of these memorized, that's a really good beginning. Okay, so let's see what we have here. So 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, okay, you guys fill that one in. What is 4 squared? If you got 16, that is correct. 5 squared is 25. 6 squared, 6 times 6, 36. All right, how about 7 squared? You guys fill in 7 squared. Hopefully you got 49 on that. 8 squared, 8 times 8 is 64. 9 squared, 9 times 9, 81. 10 squared, 10 times 10 is 100. And then sometimes we forget these last two, even though you memorized them in the past. 11 squared, 11 times 11 is 121. And 12 squared, 12 times 12 is 144. Okay, so pause the video, make sure you've got all those written on your paper so that you can use those as we are doing these difference of squares problems. Okay, so now let's do some actual factoring. So there's two different ways to do this, and I'm going to do it both ways. You guys can do it whichever way you want to. When you have a test or a quiz, you can do it whichever way you want to in Delta Math. You can do it whichever way you want to on your paper. When you do your worksheets, the important thing is that you're able to do it and you're able to get it correct. So x squared minus 25. First of all, I recognize this as a difference of squares problem because I have a minus in the middle. I recognize 25 is the perfect square number of 5 times 5 off of my list. And x squared, well, that has an understood coefficient of 1 right here. 1 is a perfect square number. And then any variable with an even exponent was something squared. You remember when you raise a power to a power, you multiply. So if we have an even exponent there, we must have multiplied by 2, which means that this is a squared term. And the way these difference of squares problems work, you're going to put your two sets of parentheses. Whatever squares to be the first one is going to go in the first spot in both of our parentheses. Now notice that it's not this thing itself, it's what squares to be that. So x squared, what multiplies by itself to be x squared? Well, that's x times x. All right, and then how about 25? That was one of our perfect square numbers. What multiplies by itself to be 25? That's going to be 5 and 5. Well, in order for that 25 to be negative, my signs have to be opposite one another. And so that is the answer to my difference of squares problem. Okay, so let's check this one. Let's see what happens when I FOIL this out. So first times first, x squared, distributing that x to both things in the parentheses, x times negative 5x. And now O, I'm sorry, that was O, the ones on the outside. Now I, the ones on the inside, positive 5 times positive x. And then L, the ones at the end, positive 5 times negative 5 is negative 25. Okay, now we need to combine like terms. I don't have anything else that's squared besides this one. What happens to my 2x to the first terms? Well, negative 5x and positive 5x are opposites of one another. They're going to cancel away. They're going to become 0. And what I'll have left is negative 25. So that's why this one only has 2 terms instead of 3. If you were going to do A, B, and C on this one, you would notice that A is a perfect square number, B is always 0, and C is the opposite of a perfect square number. It's going to be negative 25 or negative 36, but always the opposite of a perfect square number. That's the pattern that you're going to be looking for these difference of squares types problems. Okay, let's look at number 2. So number 2, I immediately notice a problem because I have a plus right here. And remember, these are called difference of squares problems because they're always going to be subtraction. And this one has a plus. So immediately I know it cannot be a difference of squares problem. But this is something squared. X times x is x squared. And this is something squared. 5 times 5 is 5 squared. And that b in the center, if I did my ABC, b would be 0. But C is not the opposite of a perfect square number. C is a perfect square number because it's positive. So this kind, the sum of squares is what we would call this because it's 2 squared things added together. The sum of squares is not factorable in the reals. So we're just going to write not factorable because you cannot factor this one using real numbers. Okay, there are some like this in Delta Math, so I need you guys to add this one onto your green notebook paper. We have 25 minus x squared. And so what we're going to need to do, that's a squared, right? A is a perfect square number, B is 0, and C is the opposite of a perfect square number. It's just that this time the variable is at the end instead of at the beginning where it normally is. But that really doesn't change anything. I'm still going to put 2 sets of parentheses. The thing that squares to be 25 is going to go first. 5 times 5 is 25. The thing that squares to be x squared is going to go second, x times x, and my signs are going to be opposite one another. And if I FOIL this one out, you can see that when I do first times first, my 25 is going to be positive, and when I do last times last, my x squared is going to be negative. So this one is written originally, quote unquote, backwards with the variable at the end. And so when I do the answer, the variable is going to be at the end of the parentheses. But there are some of those in Delta Math, so you guys just need to be prepared for that. So be sure you write that down on your paper. Okay, so let's look at this one. So I have a minus, I've got a difference. 2 and 200, those are not perfect square numbers. Those were not in my list. So I might be tempted to think that this is not a difference of squares problem, but then I remember that when I'm factoring, my first step is always to factor out the GCF. So if I divide by 2, well, now you can see I have a perfect square number here, 1 squared. I have the opposite of a squared number here, negative 100, because that 100 is 10 times 10. So now I have a difference of squares problem. So that 2 that's on the outside, that just comes down, just like what we did before. Okay, what is going to go first in my parentheses here? Well, in my parentheses, I'm going to put what squares to be x squared, which is x and x. And then second in my parentheses, I'm going to put what squares to be 100, which is 10 times 10, and then my signs are going to be opposite one another. X plus 10, x minus 10, and then don't forget to have that 2 out there in the front. The total answer needs to have the GCF with it, so make sure that's part of your factored answer. Okay, let's look at this one. So remember I told you guys there were 2 ways to do this one. Looking at the pattern is the first way. That's the easiest way. It's the most efficient way. But sometimes when we're in the middle of a test or we're in the middle of a problem, we forget. And we don't necessarily think to do things the most efficient way. So we can still do ABC on this just like we did before. So I'll do A equals 1. B equals, well, in this case, I don't see an x to the first term, so B is going to be 0, and C is going to be negative 81. All right, let's multiply A and C together, just like we have been doing. 1 times negative 81, negative 81. Okay, so I need 2 numbers that will multiply together to give me negative 81, and add together to give me 0. Well, if you get stuck, you can always do the square root of 81 in your calculator. Be careful not to type the negative part, because remember, this is the opposite of a perfect square number. You just want to type the 81. The square root of 81 is 9. So my two numbers are going to be 9 and -9. So if I substitute those in, be really careful right here. Don't just put -9 and +9. Remember that one in the middle needs to have the x's on it. So I'll have +9x and -9x. Cut it in half. Pull out my greatest common factor of x on this side. Now on the right hand side here, you can see I've got negative, negative. I need my signs to be positive, positive. So I'm going to pull out a -9. And now what I have in the parentheses matches. So x plus 9, x minus 9 are my two answers. So you can see it's the same pattern as what we had when we did it this way. It's just sometimes, like I said, in the middle of a test, you might get confused, you might forget the pattern, and so you can go back to what you're already good at, which is using A, B, and C to figure out your two numbers, and it's going to work out just fine. Okay, let's do these one of each way. So this first one, 3 and 27, not perfect square numbers. But remember, you can factor out the GCF, and the GCF in this case will be 3. Okay, now just for practice, let's do this one with our ABC. Oh, that does not look like an A. So A equals, B equals, C equals. All right, looking in the parentheses, A is 1, B is 0, and C is -9. Okay, so I need two numbers that multiply together to be -9 and add together to be 0, because A times C is going to be -9, right? Because 1 times -9 would be -9. So my two numbers are 3 and -3. All right, and when I come over here to substitute them in, I'm going to remember to bring down that 3 on the outside. Uh-oh, what did I forget? I have to remember to put an x, right? I have my x to the second term. I have my constant term with no x. I need to remember to put x to the first on these. Okay, let's cut it in half. And then we'll keep factoring from there. That 3 on the outside stays. GCF on the left is positive x. GCF on the right, I'm going to want to bring out a -3 because I need to change my signs. And what I have in the parentheses is the same. So that 3, that GCF stays. X plus 3 and x minus 3 are my two parentheses. Okay, let's do this last one using the pattern. So when I do this one, I notice that A is a perfect square number, B is 0, and C is the opposite of a perfect square number. As soon as I see that pattern, I know that I can just jump straight to my answer. The thing that squares to be x squared is x. The thing that squares to be 16 is 4. And what I have in the parentheses is plus and minus. My signs are always opposite so that when I FOIL it out, right, first times first, and then outer, distributing that x to both, inner, working on distributing that positive 4 to both of them, and these two in the middle are going to cancel out every time. That's the way difference of squares works. That's why our B is equal to 0, because the two in the middle canceled out.